Out there, in the endless ocean of darkness, our pale blue world is nothing short of a miracle. For thousands of years, humanity has looked up at the sun, that brilliant star that gives us warmth, light, and every breath of life we have ever taken. But have you ever wondered, what if Earth drifted just a little closer to the sun? How much would have to change before our world stopped being home? We live in a very special region of space, a place astronomers call the Goldilocks Zone, the habitable zone. Not too hot, not too cold, just right for liquid water and life. On average, Earth orbits about 150 million kilometers from the sun. Because our orbit is slightly elliptical, that distance changes throughout the year. At perihelion, Earth comes as close as 147 million kilometers. At aphelion, it drifts out to about 152 million kilometers. A difference of only a few million kilometers, yet enough to help shape the rhythm of our seasons. But what if that delicate balance were disturbed? Even today, Earth's hottest places push life to its limits. Iran's Dasht-e Lut desert has recorded ground temperatures approaching 70 degrees Celsius. Death Valley, on the border of California and Nevada, holds the record for the highest reliably measured air temperature on Earth, 56.7 degrees Celsius. These places remind us that life survives only within an incredibly narrow window of conditions. Now imagine Earth moving just 15 million kilometers closer to the sun. Those deserts would no longer be isolated extremes. The entire planet would begin transforming into one vast, scorching wasteland. Every second, the sun unleashes a relentless storm of charged particles known as the solar wind. These particles race through space at roughly 400 kilometers per second. Fortunately, Earth is protected by an invisible shield, its magnetic field. Without this magnetic shield, the solar wind would gradually strip away our atmosphere, exposing the surface to lethal radiation. We occasionally catch a glimpse of this power when the sun becomes unusually active. In March 1989, an intense geomagnetic storm triggered by solar activity collapsed Canada's Hydro-Quebec power grid within minutes, leaving millions without electricity for nearly 9 hours. Years later, powerful solar storms also disrupted satellites and communications, reminding us how vulnerable modern civilization is to our star's temper. If solar activity can cause this much chaos from 150 million kilometers away, imagine what would happen if Earth moved even closer. Now, let's push Earth about 40 million kilometers nearer to the sun. We arrive in the orbit of Venus. For centuries, Venus fascinated humanity. Ancient civilizations celebrated it as the goddess of love. Even many astronomers of the 19th and early 20th centuries imagined that its thick clouds concealed lush forests, endless oceans, and perhaps even alien life. Some dreamed of Venus as Earth's twin paradise. Then, reality arrived. In 1962, NASA's Mariner 2 spacecraft flew past Venus and sent back measurements that shattered one of humanity's greatest astronomical fantasies. Venus is not paradise. It is the most hellish world in the solar system. The average surface temperature on Venus is about 462 degrees Celsius, hot enough to melt lead. A carbon dioxide atmosphere hundreds of kilometers deep traps heat through a runaway greenhouse effect. Around 70% of incoming sunlight is reflected back into space by its brilliant clouds. Yet the remaining sunlight becomes trapped beneath the dense atmosphere, unable to escape. The result? A planetary furnace that has been burning for hundreds of millions of years. And then there is the rain. Not water, sulfuric acid. High above the surface, clouds produce droplets of concentrated sulfuric acid. But the air below is so unimaginably hot that the acid evaporates long before it can ever reach the ground. On Earth, the most powerful Category 5 hurricanes produce winds exceeding 250 kilometers per hour. On Venus, winds racing through the upper atmosphere can reach astonishing speeds of around 360 to 400 kilometers per hour, fast enough to circle the planet in only a few days. The planet named after the Roman goddess of love hides another extraordinary secret. Venus spins so slowly that one complete rotation takes 243 Earth days. Yet it completes one orbit around the Sun in only 225 Earth days. In other words, a single solar day on Venus is actually longer than its entire year. Even stranger, Venus rotates backward compared to almost every other planet in the solar system. Stand on its surface, and if you could somehow survive, you would watch the sun rise in the west and set in the east. But suppose we continue our journey deeper into the solar furnace until we reach Mercury, only about 58 million kilometers from the Sun. The first dramatic change would involve gravity. The Sun's gravitational pull is so overwhelming at Mercury's distance that stable natural moons cannot survive there. If Earth somehow occupied Mercury's orbit, our beloved moon would eventually be pulled away by the Sun's immense gravity, doomed to spiral into the blazing heart of our star. Mercury has almost no true atmosphere. Over billions of years, the relentless solar wind has stripped away nearly all of its gases. Here on Earth, our blue sky exists because sunlight scatters through molecules in the atmosphere, a phenomenon known as Rayleigh scattering. But Mercury has no such protective blanket. Even in broad daylight, the sky would remain pitch black, while the sun blazes overhead with terrifying brilliance. Mercury's day and night cycle is one of the strangest in the solar system. It rotates once every 59 Earth days and completes an orbit around the Sun every 88 Earth days. But because of the interaction between its rotation and orbit, one solar day, from one sunrise to the next, lasts an astonishing 176 Earth days. Imagine standing there, waiting nearly half an Earth year for the sun to set. During the endless daytime, temperatures soar to around 430 degrees Celsius. Then, during the impossibly long night, they plunge to nearly minus 180 degrees Celsius. A world where lead melts beneath your feet by day, and the cold of deep space freezes the landscape by night. Our beautiful blue planet is not simply the product of chance. It is the masterpiece of an extraordinarily delicate cosmic balance. Move Earth only a few million kilometers closer to the sun, and our oceans begin to disappear. Move a little farther still, and our world starts resembling the toxic inferno of Venus. Push it deeper into the sun's domain, and it becomes a scorched, airless world like Mercury. The universe teaches us a profound lesson. Survival is not guaranteed by size, strength, or intelligence alone. It depends on balance, on fragile conditions maintained across unimaginable distances. In the vast, unforgiving emptiness of space, Earth is more than just another planet. It is our only home, and perhaps the rarest miracle we have ever known.